start with number 11. Alright, we had the natural log of x plus 7 minus the natural log of 3 equals the natural log of 7x plus 1. So we did one kind of along these lines yesterday. If I'm looking at this, I have two natural logs over here. We have to start by somehow combining those. If your logs are subtracted, how do you put them together? Division. So this becomes the natural log of x plus 7 over 3 equals the natural log of 7x plus 1. Now the example we did yesterday only had the log on one side, so then we just used the definition. If you have a log on both sides, it's actually even easier. Those logs just drop off. So the arguments have to be equal. So I could multiply them by 3. So I get x plus 7 equals 21x plus 3. If I subtract over my 3 and subtract my x, and divide by 20, so x is 1/5. You should check with this. The rule with logs is when you plug it in, the argument has to be a positive. So 1/5 plus 7 is positive, 3 is positive, 7 times 1/5 plus 1 is positive, so it works out. Any questions there? Number 12, we have 8 to the 3x plus 1 equals 1 over 16 to the x minus 4. Alright, with this, we can check first to see if common base is an option. If that works, that is going to be the fastest approach. If it doesn't, then we can add logs. So can we get a common base on this one? Yes. So I could change my 8 to 2 to the 3rd. Okay, 1 over 16. First of all, if it's on the denominator, if I need to change floors, you have to make it a negative. 2 to what power equals 16? Right. Then we have a power to a power, so what do we have to do with those? Multiply. So you get 2 to the 9x plus 3 equals 2 to the negative 4x plus 16. So then we can drop the base and set those exponents equal to one another.
Okay, I need the current algebra.
So then we can add our 4x over. And if we subtract our 3, and we get x equals 1 plus. And these are nice and easy to check. You can always just plug them back into your exponents. Alright. Problem 13 looks the same, but it's a little bit different because is it possible to get a common base on that one? No. If you can't get a common base, that's when we added a log to each side. And if you add a log to one side, you have to do it on both. The reason we add that log is because of the properties. What can you do with your exponent? So I do need to distribute, so we get log 3 minus 2x log 3 equals x log 4. If I'm looking at this, I have two x's. You need all the x's on one side, so we're going to add this term over. From there, these aren't like terms, so I can't actually add them. What do? You can pull out that x. And then to get x by itself, you would divide. So x is log 3 divided by log 4 plus 2 log 3. These are the ones to put in the calculator. You do need to be careful. Every time you push log, it opens a parentheses, so you need to make sure you're closing it. You also need parentheses around the entire denominator. And so if you put that in your calculator, you get 0.3066. Nice thing about these, you can check them very easily. Just take that decimal, plug it back into the original, and see if it works out. Questions on that? Problem 16. Okay. We have 3 variables, so we're going to take 2 equations at a time and eliminate something. If I took the first 2 equations, what could you easily eliminate? The y. You don't even have to multiply by anything. We have 5x minus y minus z equals 0, and x plus y equals 5. So if I add these, 5x and 1x gives me a 6x, positive y and negative y cancel, minus z equals 0 plus 5 is 5. You have not used this third equation, so we have to use this one in one of the other 2, and we need to eliminate the same variable again, so we need to eliminate y. However, do I even have a y in that one? No, so we kind of got to skip a step here. I have 2 equations that both have x and z in them, so I can put these together. I need to eliminate one of those variables. What do you want to eliminate? Okay, so take this one times. So our first equation is the 2x.
Algebra B students, please report to the library for your EOC.
So if we add these together, those drop. 2x and negative 18x is negative 16x equals negative 13. Divide and we get 13 over 16. Now that I have my x, we can start working backwards to get the y and the z. So if I want to plug that one in here, we have 6 times 13 over 16 minus z equals 5. So what does that give us? So if I subtract over my 39 over 8, I get negative z equals 1/8. Divide by negative 1, so z is negative 1/8. Now I have x and z, so we have to plug it in somewhere to find y. Let's just do the x plus y equals 5. So x, 13 over 16, plus y equals 5. Subtract that over, and you get 67 over 16. So the answer, we put them in alphabetical order, X, Y, Z. And again, easy to check because you just have to plug that into the original equations and it should make all of them work. And you can use your calculator to do that. Any questions on that? Let's look at problem 18, a nonlinear system. The strategy is still the same. We can do substitution or elimination. What do you want to do? Okay, so to get rid of the x squared, we have to take the top one times. So we get negative 10x squared plus 4y squared equals negative 50. The bottom one, 10x squared plus y squared equals positive 50. Add those together, those cancel. 4y squared and 1y squared is 5y squared. Negative 50 and positive 50 is 0. Divide by 5. How do you get rid of a square? And if you have a square root, we do plus and minus, but it doesn't really matter because positive or negative 0 is the same thing. So we just get y equals 0. Now we need our x. So we're going to plug that into either of the original equations. I'll just do the second one. So I have 10x squared plus 0 squared equals 50. So that means 10x squared equals 50. So x squared is 5. To get rid of a square, you square root, plus and minus. So that's positive and negative. Square root of 5. So that 0 gave me two answers, so we have two ordered pairs. Radical 5, comma 0, and negative radical 5, comma 0. Questions there? You guys didn't ask about 19. That was the one I did not have on my answer key, so I'm just going to do it really quickly for you. What's this first graph? Parabola. I told you that I would check to make sure you had a minimum of 3 exact points. So you could plug them in, or you could do transformations. If you put in a 0, you get out negative 6. If you put in 1, you get out 1 minus 6 is negative 5. Put in negative 1, negative 5. Is that solid or dashed? Solid, because of the equal to. Okay, so to figure out where to shade, if you put in 0, 0, you get 0 is less than or equal to negative 6. Is that true or false? False. So 0, 0 does not work, so that means we're shading outside this parabola. Second, we had x minus 2y is greater than 6. So this is a line. We can solve for the y. So if you subtract your x, divide by negative 2, what does that do to our inequality? You get 1/2 x minus 3. So start at negative 3. Slope is 1/2, so up 1 over 2. Solid or dashed for that one? That one's dashed because it didn't have an equal to. Okay, you might know less than is below, or if you plug in 0, 0, you get 0 is less than negative 3, which is false, so 0, 0 doesn't work, so you're shading below that line. So overall, we are shading below the line and outside the parabola. questions on that? Problem 20. We have 2m. M here represents a matrix. So this is just a matter of solving an equation, but our answer will have a matrix. So we would solve it like any other equation. We want to get the m by itself. So first I have to get those together. What would we do? Add this m. That gives me a 3m. What should I do with this matrix? Subtract. We talked about to subtract a matrix, if it helps, you could distribute a negative to everything and then just add them. So negative 6 plus negative 5 is negative 11. 2 plus negative 4 is negative 2. 0 plus 1 is 1. 4 and negative 8 is negative 4. And then, how do I get m by itself? Divide by 3. So to divide a matrix by 3, you divide every single number in there by 3. So that's negative 11 thirds, negative 2 thirds, positive 1 third, and negative 4 thirds. And the last one, problem 21. Find the present value. What variable is present value? P. Needed to get $600. So 600 is what we want in the future, so that is A. After 3 1/4 years, so that would be T, and we'll do 3.25. T always has to be in years. At 6%, so that's my R is 0.06. Compounded daily, so N number of times a year. I gave you the formula. The only time you use the formula with the E is if I say continuously. So plug in my A is 600 equals P 1 plus 0.06 over 365 to this 365 times 3.25 power. What do you have to do to get P by itself? Divide. You can put this in your calculator now, or you can just do it all at once. Just 600 divided by that entire thing. So I plug all of that in. You get $493.71. Any other questions there? So today, you've got the rest of class to finish this study guide. Tomorrow, we will go over questions on the last page, the 22 through 28, and then any extra time that I have, I'll just be giving you some extra problems, talking about what will be on our final. With the inequalities, it's a little more complicated. On problem 23, you just multiply to get rid of the fraction. I can't do that here because, do you know if 5 minus 3x is positive or negative? No. And with inequalities, if you multiply by a negative, it flips your sign. So because I don't know if it's positive or negative, I wouldn't know if I had to flip my sign or not, so I can't do it. So instead, we have to get a particular setup. We want a fraction on one side and 0 on the other. So if I'm looking right now, we need to bring over that 2. Okay, so I can subtract that over. That gives me the 0. Now, I need this to be just one fraction. Currently, that's like a 2 over 1. If you want to put those together, you have to have a common denominator. So what I'm going to do to get a common denominator is take this times 5 minus 3x on top and bottom. Okay. You could think of this as a negative 2. So if I do that, I get negative 10 plus 6x over 5 minus 3x is greater than 0. Now those denominators match, so we can put them together into one fraction. So you combine like terms on top. So 6 and negative 10 is a negative 4 plus 6x is greater than 0. Alright, at this point, if I want to get a positive, that can happen 2 ways. If you take a positive number divided by a positive number, or a negative number divided by a negative number. So what we had to do was set up what's called a sign line. So part A starts here. You have your fraction greater than 0. So at this point, what we do is set the top and the bottom both equal to 0. We're going to find those numbers. Okay, so this one, if I add my 4 and divide, we get 2/3. And this one we get 5/3. We think about a number line. If I plot only those two numbers, smaller number on the left, that's positive 2/3, positive 5/3. Those are the places where we either have an asymptote or our graph equals 0. We can either plug in numbers. Some of you, I think a few of you like to do that. Most of you just like to look at a graph. So let's go to our graphing calculator. And we are graphing this fraction right here. When you plug that in, you need parentheses around the top and parentheses around the bottom. So I have parentheses negative 4 plus 6x over parentheses 5 minus 3x. Okay, so I can see, before I get to 2/3, my graph was below the x-axis, right? So it's negative. After 2/3, my graph is above the axis, so that is positive. After 5/3, my graph is below, which is negative. You wanted your graph to be greater than 0. Greater than 0, is that positive or negative? Positive. So that's right here. No equal to, so that means parentheses, so it's everything between 2/3 and 5/3. That means any number in that interval would make the original problem true.